Chapter 7, this is day 3, and we are going to work on multiplying polynomials today, but I'd like you to start with this warm-up for review. I would like you to try these problems, and then if you can then pause the video, and I'd like you to check your work and correct your work using the notes posted. So we are going to use the distributive property to multiply polynomials, and then I'm going to teach you something called the box method and the FOIL method, which really are all the same result, but just different ways of thinking about doing the problem. So remember from the past, okay, when we multiplied monomials, if we had something like x to the fourth times x to the third, if we wrote that out, that would be 4x's times 3 more. So our answer would be x to the 7th. And in general, when we have the same base, x, and we're raising it to a power, and then we're multiplying by that same base to a different power, we're just adding those exponents together. And this is sort of the reason why, okay? And then we did more complicated ones, where we had to sort of think about 3x to the third times 6x squared as multiplying all of these pieces together. And if we wrote these out, we would have 3 and then times x times x times x. And then we'd have the 6 times 2 more x's. And so rather than writing it all out the long way, what we discovered is we can just multiply the two numbers together to get 18. And then again, we're going to be adding those exponents together to get the 5. So I'll go through one more of these, and then I would like you to, again, maybe try one or two on your own to see if you can do it correctly. Check the notes to make sure. So if you look at, we'll try number 1 together. If we look at number 1, okay, we have a negative 3 times a 4. Okay, so those numbers multiplied together would just be negative 12. That's just multiplying like you normally do, or use your calculator. But when we look at the x to the third right here, times x to the first, that's going to be x to the fourth, or 3x's multiplied by 1 more is x to the fourth. And then we get y squared times y to the third would give us y to the 2 plus 3, or 5th power. Okay, so this is how these work. Okay, and that now we're going to, right now, these were all multiplying just one term times one term. Yeah, the one term, the monomial, had a product of both numbers and combinations of letters, but we were still just multiplying. If you think about this, what we're doing is we're multiplying one term times another term. Okay, so again, there's more practice here that you can try, and then check the notes to make sure you're understanding what we've learned in the past, because we will need that going into the future. So this is what we are working on today, is we are multiplying polynomials, so more than just monomials, one term. And you can see in this example, first example right here, we're multiplying a monomial of 9 times a binomial, 2x minus 3. And what we can do when they're pretty simple, just a monomial times some other polynomial, is use the distributive property. And we've done this before, where when we use when there's a number or a letter outside the parenthesis, we have to multiply it to each term inside the parenthesis. So a times the quantity b plus c would be a times b plus a times c. Okay, and there's a couple examples above, but let's show you and remind you how this works with 9 times 2x minus 3. We have to take the 9 times the 2x, and we have to take the 9 times negative 3. And so when we multiply 9 times 2x, that would equal 18x. And when we multiply 9 times negative 3, that would equal negative 27. And then that would be our answer. Okay, let's try another one. This one is a little bit more complicated, simply because we have 6x is our monomial. So now we have to take 6x and multiply it with the x. And we have to take the 6x and multiply it with negative 3. So again, I would suggest you write these out, and you'll see that 6x times x is 6x squared. And 6x times negative 3 is negative 18x. So hopefully you're understanding this a little bit better. So I'd like you to try the next one. Pause the video right now and then restart it and listen to the explanation and the correct answer. So when we take negative 2x times x, that is going to equal negative 2x squared. And when we take negative 2x times 2, that is going to give us negative 2x. So that should be your correct answer. All right. So here are a bunch more examples, okay? Using the distributive property with a monomial, again, one term. All of these just have one term in front, okay? Then we're multiplying it by a binomial in these first two cases or a trinomial in the second two cases. So of course it gets a little more complicated. So what I'm going to do is I'm going to work through two of them with you, and then you're going to try the other two on your own. So if we look at, I'll do the first one, number 4. So we take we take negative x and we multiply it by 2. So negative x times 2, and we take negative x times negative x. So negative x times 2 is negative 2x. And negative x times negative x, and negative times a negative is a positive, and x times x is x squared. So that is our answer. But notice, this is important, that whenever we give our answer, we always rewrite this in standard form. This is not in standard form. Okay, in standard form, the x squared term would come first, and then we would have plus a negative 2x or just minus 2x. So that is our answer right there. Okay, you try the next one, okay? Then pause the video, try the problem, and then restart the video to see if you got it correct. So I am taking 7xy times negative x, and that would give me 7x squared y, but notice it's a positive times a negative, so it's going to give me a negative 7x squared y. And now I have to take the 7xy and multiply it with 3. So the 7 times the 3 gives me 21, so it's plus 21xy. 21xy. So again, written in standard form, this is already in standard form, so I can just rewrite it, negative 7x squared y plus 21xy. So that is our answer. We really didn't need to rewrite it in standard form, but I thought I would make sure it was clear. All right, let's do this next one together. We are doing 5x squared y times y squared and times the middle term and the last term. And I really encourage you to write out what you're multiplying. You don't have to. Some of you are good at keeping track in your head, but 5x squared y times x squared is going to give us 5x to the 4th y. Okay, now I take 5x squared y times negative 4z, and that is going to give me 5 times negative 4 is negative 20 x squared yz. And again, I need to do that last term, so I would take 5x squared y times xy, so that would give me 5x to the 3rd y squared. Now, these are a little trickier to write in standard form, so we usually pick the variable that is first in the alphabet, so that would be the x, and we put them in order of the highest exponent power of 4, and then the x to the 3rd power, and then the x to the 2nd. So these terms in order of standard form would be 5x to the 4th y. I'm going to clean that up a little bit. 5x to the 4th y. Then the next term would be the 5x to the 3rd y squared. And then finally, minus 20x squared yz. All right, that was a little trickier. All right, the last one, number 7, not too bad. Pause the video, try it, and then check the notes to see if you got it correct. All right, so those were just a monomial times another polynomial. But what if we wanted to find the area of something? Okay, to find the area of a rectangle, we have to take the length times the width. Well, this is the length right here, and this is the width. So in order to find the area of this rectangle, I would have to take x plus 3 and multiply it with x plus 4. And that becomes a little bit more complicated because now we have a binomial times a binomial. And so this gets a little more complicated. Well, one thing you can think about is just applying the distributive property twice. So in other words, if this 3 needs to multiply to each of those terms, well, so does this x needs to multiply to each of the second two terms. So that's really what we do. So I'm going to do kind of some color coding here to maybe make this a little simpler. So first I'm going to take the 3 times the x, which is 3 times x, 3x, and I'm going to take the 3 times the 4, which is 4x, and that's my multiplications for that first piece. Okay, now I'm going to do the same thing in a different color. I'm going to take this x right here and multiply it to the x, which would give me x squared, and I'm going to multiply the x times the 4, which would give me 4x. Now, none of these are negative. Oh, I'm sorry. The 3 times the 4 is actually 12 here. That's my bad. So I'm just going to go back. This was the 3 times the 4, and that was actually 12. And so now when you look at all of these terms, okay, they are all, there's no negatives there, so we're just adding all these together. That's our expression for area. But just like before, if we have like terms, we can add them together. So 4x and 3x get added together for a total of 7x. So the area of this is equal to x squared plus 7x plus 12. That is our answer, and it is in standard form, so we're good to go. You're not going to get a single number answer for area for these problems. Now, if you were given that x is equal to 1 or 5 or something like that, then yeah, you can go ahead and plug the x in and get an actual value for the area. Now, sometimes that gets kind of tricky. I think the distributive property twice, just thinking about it that way, makes sense. But there are other ways to do this, and some people actually really prefer what's called the box method. And these are the steps for the box method. Is we draw a box so that if we have a binomial times a binomial, we're going to need 2 boxes by 2 boxes. If we had a binomial times a trinomial, it would be 2 by 3. Okay? We're going to write this polynomial right here on the top. So x plus 4. We're going to write this one over here, x plus 3. Okay? And it doesn't matter if I switch those up. But now I'm going to multiply each row by each column. So in other words, I have to multiply the x and the x together to get x squared. I'm going to multiply the 4 times the x to get 4x. Okay, then I have to multiply the x times the 3, that gives me 3x, and I multiply the 3 times the 4 to get 12. And if you look at those terms, I don't know that you remember it, but we actually got those exact same things on this last problem. We got x squared, we got 4x, we got 3x, and we got 12 because it is the same problem. So now we're just going to add all of those terms together, but we can only add like terms. So those are the only ones that can get added together. So that means we would have, putting it in standard form, x squared plus 7x plus 12. Okay, and again, always writing it in standard form, which means we are going from the highest exponent power to the lowest. That is our standard form. So box method is another way to solve these. And here's another one you can practice, try it, and then check the notes, see if you got it right. If you like that method, continue to use it. A third way to think about this is something called FOIL. Okay, so again, another way to multiply a binomial times a binomial, okay? And it's just really the same thing as doing the distributive property twice. It's just a way to remember to do it, which is FOIL. So what we can think of with FOIL is we can think about our F in FOIL is for our first 2 terms. So it's the first term in this parenthesis, and it's the first term in the second parenthesis that gives us so it's our first term times our first term. and that multiplication is our f, or first terms. Okay, and I'm actually going to write these f's above. I think that will be less confusing. So this is our first term and our first term multiplied together. So x times x is x squared for our first term. Okay, now let's work on the outsides. Okay, the outsides are the outermost numbers in your problem. So this is our O and our O. So this is our outside multiplied together, and that would give us x times 3, which is 3x. Now let's do our inside terms. Our inside terms are, again, this term right here and this term right here are innermost terms, so we can call it that inner or we can call that inside, but that is going to be 4 times x, or 4x. And then last but not least, pardon the pun, is our last term. So this is our last term in the parenthesis, and this is the last term in the parenthesis. So this is our last terms multiplied together, which is 4 times 3 and 12. Okay, so again, those are the same 4 things we got on that last problem. So now we can combine any like terms. The 3x and the 4x get combined together to get 7x. We add that with the 12 and the x squared, with none of those are like terms, and then that is our final answer. So FOIL is another way to do it. It's kind of a standard in mathematics. A lot of teachers will mention the word FOIL, but there are other ways to do this. So we have another example of the FOIL method. Again, another one you can try and see, check the notes to see if you got it correct, and then kind of make a determination which of these methods you prefer and continue to use that one. We do have some additional examples here that I will put on some of those examples in the notes, but this is the end of the video portion of day 3.